Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss how to apply law of conservation of momentum when there is no any physical contact between two isolated bodies. And this concept I will explain you with the help of past paper question from Cambridge ES Physics. First of all, let's try to understand what is given to us. If we read this question carefully, it is given to us that there is a rock R of mass this much. The mass is given to us and is at a large distance from a star S. And the rock is traveling at the speed of the rock is given, and mass of star is also given to us. And rock reverses its direction of motion and has the same speed as initially at a large distance gain. If we look at this diagram, it is also given to us at this point we have this rock. It is at a large distance from this star. So this S for star, and the speed of rock is given, mass of rock is given, and mass of star is given to us. And the speed of rock is also given here. So at this point rock is moving to the right and here rock is moving to the left. Now what we need to find out, simply we need to find out which statement is correct. We have four options, we have to choose the right one. Now in this case, if we study this system carefully, one thing we can conclude is that this is isolated system as there is no any other object in its surroundings. So we can treat this system as an isolated system. And also the second thing what we need to understand is that in this system these two bodies are interacting with each other. So this is a special kind of collision. So we can also write down this is a special kind of collision in which two bodies are interacting with each other. So this is second thing we need to understand. Now as we understand now, it is a kind of collision in which bodies are interacting with each other and they're exerting force on each other even there is no any physical contact between them. So we can use law of conservation of momentum. So let me explain to you first of all few important points and then we will use those points and we will answer this question. Let's say we have two objects. Let's say we have object X and we have another object. This is object Y. And these two objects, they collide with each other. So the Y will exert force on X. We will say this is force on X by Y, force on X by Y, and there will be force on Y by X, force on Y by X. So I will simply say this force Fx and this force I will simply say this is Fy. Now these two forces, the magnitude will be same even the direction is opposite. We can simply say Fx is equal to Fy, the same magnitude. They have same magnitude. Even direction of force on these two objects is different. Now second thing we need to understand, the time of impact means the time force Fx is acting on X is the same as the time for force Fy acting on object Y. So time of impact is also same. Now if I write like this, Fx Tx, this also will be same as Fy and Ty. And Fx Tx, if we remember, so the product of force and time of impact, that is called impulse. So we can say impulse is also the same, the magnitude. So you have to be very clear here. We are simply talking about magnitude. So magnitude of impulse on X and magnitude of impulse on y is the same, but direction is different, direction is opposite, but magnitude is the same. Change in momentum. So the change in momentum for x and change in momentum for y is also the same, magnitude is the same. Even the change is in opposite direction, but magnitude is the same. So this is all what we need to understand. If you're very clear about this one, this question is very simple to answer. Now, first of all, let's look at option A now. What option A is telling us? Option A is simply telling us the change in momentum of S is in direction of arrow X. Means the change in momentum for the star is to the left. So let me redraw here. So this one is over star. We can say this is S. At this point, the rock is at this point. So this is R. So the rock is at this point. Now, between these two objects, there is gravitational force. So the rock is pulled to the left and the star is pulled to the right. As the resultant force on star is to the right, so the change in momentum also has to be to the right. So the delta P, the change in momentum for this star, it has to be to the right. But option A is telling us it is to the left. So this is not right option. Now let's move on to B now. The change in the velocity of X is approximately 20 meters per second. So this is based on calculation. We will do calculation later. Let's move on to next one. Option C is telling us the magnitude of the change of momentum of R. Magnitude of change of momentum of R is 10 to 3 times greater. No, that's wrong. This is not right, because we have discussed the change in momentum in magnitude is the same for two interacting objects. So this is also not our answer. Momentum of R does not change. But momentum of R is changing because momentum is a vector quantity. So even speed is the same, but velocity is changing. So momentum is changing. So this is also not right answer. So our answer is B. Let's do calculations and find our answer. We have already discussed that the magnitude of change in momentum for rock and also the magnitude of change in momentum for star, they are the same. Now simply we need to calculate change in momentum. Now first of all, let's try to find out change in momentum for rock. As you can see here, at this point the rock is moving to the right and here the rock is moving to the left. Now we need to find out change in momentum. As momentum is a vector quantity, so we need to decide one direction as positive. So in this case, let's say to the left is positive. If we take to the left is positive, we can also then this velocity will be negative and this velocity will be positive. Now we need to write down the change in momentum, so we can say this will be V minus U, and for the star we will simply write down the mass of star and we will just simply write down delta V, because we need to find the change in velocity. So this is our change in velocity. This is what we need to find out. Now in this case the mass of the rock is given, so we can just plug in values. Mass of the rock is 1.0 times 10 to 27 kgs, and the V in this case, this is 1.0 times 10 to 4, this is plus, minus, and as this initial velocity is negative now because we took to the left positive, so we will plug in here, this is minus, so this is minus 1.0 times 10 to 4, and here we have mass of star, that is 1.0 times 10 to 30 multiplied by delta V. Now you can see here, if we need to simplify this one, so we will get this is 1.0 times 10 to 27, and here we have 1.0 times 10 to 4 plus 1.0 times 10 to 4, and this is equal to 1.0 times 10 to 30 times delta V. So from here, if we just plug in these values in our calculator, we will be able to get delta V, that is 20 meters per second. So this is our correct option. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, I will explain you some questions about kinematics and measurements. All of these questions are from Cambridge AS Physics past papers. This video will help you to improve your conceptual understanding of kinematics and measurements. Here is our first question, and this question is simply asking us about SI base units. As you can see here, SI base units, not quantities. So often students, they get confused with units and quantities. So actually there are 7 SI base units and 7 SI quantities, as you can see here. In this column we have SI quantities. As you can see, the length is a quantity, its unit is meter. We have mass is a quantity, its unit is kilogram. Time, seconds. Temperature, Kelvin. Electric current, amps. Luminous intensity, candela. Amount of substance, volt. So these are 7 SI base units and 7 SI quantities. So we need to be quite clear with this one. If we are clear about these 7 SI base units and quantities, then this question is very simple to answer. So we simply need to find out SI base units, the pair of SI base unit. So if we look at amps, this is SI base unit, but joule is not SI base unit. So answer is not A. Coulomb is not SI base unit. Second is SI base unit. If we go to C, SI, kg is SI unit, and Kelvin is also SI unit. Meter is SI unit, but Newton is not SI unit. So our answer for this question is C. For this question, we simply need to understand what exactly is 1 micrometer and what exactly is 1 gigameter. So first of all, let me explain to you what is 1 micrometer. So this is 1 micrometer. 1 micrometer simply tells us that it is equal to 10 to the power of minus 6 meters. And 1 gigameters is simply equal to 10 to 9 meters. Now, if we have this understanding, if we remember what is micrometer, what is gigameter, then simply we can answer. So as 1 micrometer, we simply understand 1 micrometer, and this is divided by 1 gigameter. So 1 micrometer is simply equal to 10 to minus 6 meters, and 1 gigameter is simply equal to 10 to 9 meters. So if we just simplify this one, our answer will be 10 to minus 15 meters. So our final answer is D. For this question, we need to find out what gives the value of a body's acceleration. Means how we can find acceleration if displacement time graph is given, velocity time graph is given. So as you can see, in all these options, we have velocity time graph and displacement time graph. So we need to understand how we can find acceleration of a body if graph is given to us, simply if a graph is given to us. So first of all, let's try to understand what is acceleration. So acceleration simply is equal to delta v over delta t, or we can also say that this is equal to rate of change of velocity, rate of change of velocity. As this is the rate of change of velocity, we can also say that we can find acceleration from the gradient of vt graph, means from the gradient of velocity time graph we can find acceleration. So this is simply what you need to understand. So in this case our answer is first of all, let's try to understand what is given to us. For this question, it is given to us a stone is dropped from the top of a tower of height 40 meters. A stone falls from rest and air resistance is negligible. What we need to find? We need to find the time taken for the stone to fall the last 10 minutes to the ground. So this is very important. We need to understand the last 10 minutes to the ground, not the total time taken. So the best way to answer this question is, first of all, sketch. So we can simply sketch this one. Let's say this is stone. It is dropped from this point. Its initial velocity is equal to 0. And let's say ground is here. This is ground, and you can see as the distance is given, the height is given is 40 meters. So it simply means that this distance is equal to 40 meters. So we can simply say this is equal to 40 meters. We can also say this is S. Now at this point it is also given to us that 10 meters. Let's say this distance is S1 and this one is equal to 10 meters. If this is 10 meters, then we can also find out S2. So the S2 in this case will be equal to 30 meters, means 40 minus 10. So how we can answer this question? So this question can be answered in many ways. We can use different approaches, but I will explain you one, the simplest one, the simple one. So if we can find somehow what is value of v1 at this point, and also if we can find out what is value of v2 just when it strikes the ground, then it will be very easy to find our final answer. If I have, let's say, v1 and if I have v2, so then simply we can find simply using the formula v is equal to u plus at. And so in this case v will be equal to v2 and u will be equal to v1, and then is a and t. So t we will find very easily. So the t will be equal to v2 minus v1 over a. So we will find. So for a is given as it is in free fall. So this is in free fall because a resistance is negligible. So we can say in free fall. So it means that g is equal to a, and that is equal to 9.81 meters per second per second. So we can also write down the unit here, meters per second per second. Now how we can find v1 first of all? So first of all, just look at s2 now. At this point velocity is given, u is equal to 0, s is given. So we can find v1. So I can write down here for s2, we can say for s2. As s2 is equal to 30 meters, so we can find out value of v1. So simply we can find out that 2as is equal to v square minus u square. So we need to find v square. So v square in this case is equal to v1. So if we just simplify this one, we will get that is equal to 2as, the root of this one.
that is 2as, and if we solve this, in this case s is equal to s2, and our answer will be 24.3 meters per second, 24.3 meters per second. So this is value of v1. Now the second thing we also need to do is we need to find out v2. So we will say for s is equal to 40 meters, we will repeat the same steps. So if we repeat the same step, means 2as is equal to v square minus u square. So in this case, we can find out value of v2, that will be equal to 2as. We just need to take the square root of this one, that will be equal to 28.0. So that will be equal to 28.0 meters per second. Now as you can see here, we have value of v1, we have value of v2, so we can simply use this formula. So we just need to use this formula and we can find out value of time. So it means time is simply equal to v2 minus v1 divided by a. So the v2 is equal to 28 and the v1 is equal to 24.3 meters per second, and a is equal to g, that is equal to 9.81, and if we just solve this, our final answer will be 0.38 seconds. It means this is the time taken for the stone to fall the last 10 meters to the ground. So our answer is A. Here is our question number 5. Question number 5 is about uncertainties. So let's try to understand first of all what is given to us. For this question, it is given to us that resistance is equal to potential difference divided by current. And the absolute uncertainty of potential difference is given, and also the absolute uncertainty for current is also given. So absolute uncertainty for potential difference is 0.05 volts and for current is 0.01 amps. Now the question is that how we can find out the percentage uncertainty in the value of R, means in the value of resistance. So for this one, the main concept what we need to understand is that when quantities are multiplied or quantities are divided, we need to add the percentage uncertainties. So this is the main concept as you can see here. So when quantities are multiplied or quantities are divided, we need to add the percentage uncertainties. So as you can see here, absolute uncertainties are given, means the delta V is given here, and absolute uncertainty here, delta I is given. Now how we can calculate the percentage uncertainty in resistance? So this is quite straightforward concept if you remember from our class. So delta R over R is equal to delta V over V plus delta I over I. So as we need to calculate the percentage uncertainty, so we have to multiply by 100. So we need to calculate the percentage uncertainty. It simply means that we have to multiply this by 100. So as you can see, the delta V is given, that is 0.05 divided by 1.00 plus we have delta I by I, that is 0.01 divided by 0.50. We have to multiply this by 100 because we need to calculate percentage uncertainty. So if we solve this one, our final answer will be 7.0%. This is the percentage uncertainty in R. Percentage uncertainty in R is equal to 7.0%. So this is how we can answer. So the main idea is that we need to understand when quantities are multiplied or divided, the percentage uncertainties are added. So our final answer is C. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. Today's lesson, we will talk about kinematics and measurements. This is our second lesson on kinematics and measurement questions from Cambridge AS Physics past papers. Here is our first question for today's class. Let's try to see what is given to us and what we need to find. If we read this question carefully, we can simply find out the 4 students, they did one experiment and they made a series of measurements to find the value of G. Means free fall simply means we ignore air resistance. So what we need to find out, we need to find out which set of measurements is precise and which one is not accurate. Means which set is the option A, B, C, D is precise but not accurate. So to answer this question, we need to understand the exact meaning of precise and accurate. So let me explain to you what exactly is precise and what exactly is accurate. So the precise, as you can see here, I have already written for you to save our time and to finish this video quickly. As you can see, precise means that the measurements are close to each other. So what exactly it means? So let me give you one example. Let's say we have 2 sets of data. Let's say one set is 24.1 and 24.2. Another set of data, let's say we have 24.0 and 24.4. Now we need to find out which set of measurements is more precise. So means we just need to find out which measurements are close to each other. So one way to determine that can be we find the difference between them. We can find out 24.2 minus 24.1. As you can see, the difference between these two values is equal to 0.1. And if we find the difference for the second set, we can find out 24.4 minus 24.0. The difference between them is equal to 0.4. So from here we can simply conclude that this set is more precise. So this is what exactly precision is. So this set is more precise. So based on this one, we will determine which option is more precise. Okay, the second thing we need to understand, accurate. So what's meaning of accurate? Accurate, we can also understand simply accurate means correct. So this is common language, means correct. So what exactly means? The measured value is close to actual value. So it simply means that the actual value of anything is equal to, is close to, not exactly equal. So we can say actual is equal to measured value. So what exactly it means? So let me give you one simple example. So example can be, as you can see, the actual value of G. So this one is the actual value of G. Actual value of G is equal to 9.81. Let's say we got two measurements. We got one measured value. I will just simply say MES. Let's say we got one is 9.7 and other one we got that is, let's say, is 9.6. So make it simple. So which one is more accurate? Accurate means which one is closer. Simply it means which one is closer to 9.81. As you can see, 9.7 is closer to 9.81. So we will say this one is more accurate. So we can say this one is more accurate. So this is how we can determine accurate. So this one we will say is not accurate because it is not close to 9.81. Now we understand what exactly is precise, means the meaning of precise, and also we understand meaning of accurate. So let's try to answer this question now. So means now let's try to find out the best possible option. Best possible option, let's try to find out. If we look at option A, as you can see here, 9.81, 9.79, 9.84, 9.8. These values are very close to each other. So we can say that these values are precise. And also they are close to 9.81. We can also say these values are accurate as well. But this is not our answer because our answer has to be, measurements has to be precise but not accurate. So this is not best possible answer. If we look at option B now, you can see the first one is 9.81. This is 12.12 is greater than, but this is 9.89 is still close to 9.81, and this is 8.94. So this is close to, this is exactly 9.81, but these values are greater than 9.81. So overall result will be greater than 9.81, but still is close to 9.81. So we can say that this is accurate. So this result is accurate as compared with the others. So we can say this is accurate. And as the values are away from each other, you can see the difference between 10.12 and the smallest one, 9.81. So we can say is not precise. So it can be accurate, but it is not precise. But if we look at this option now, you can see 9.45, 9.81 or 9.21. 8.99, 8.76, and all of these values are smaller than 9.81. So this set of value is not accurate. Actually, there is a kind of systematic error. So but if you are not clear about systematic error, no problem, but due to systematic error you can see a trend. All the values are just smaller than 9.81. So there is systematic error. If you didn't remember what is systematic error, no need to worry. So we can simply say this is not accurate. So we can say this one is not accurate. But also we can see this is 9.45 and 8.99. There is a big difference as compared with other values. We can say this is not accurate, but this is also not precise. Now the last one, so this is also not our best possible option. This is also not best possible option. But if you look at this one now, you can see this is 8.45 and this is 8.46, very close, 8.50 very close, and 8.41. Even all these values are smaller, there is also systematic error because all these values are just lying on one side of actual value. So there is also systematic error. So we can say these values are precise because they are close to each other, but these values are not accurate because they are not close to 9.81. So our best possible option for this question is D. For this question, it is given to us that a football is dropped from the top of a tall building. So this is important, from the top of a tall building. And also it is given to us that the air resistance is not negligible. So for this type of question, we need to check always for air resistance. Is the air resistance is negligible or not? For this question, air resistance is not negligible. So now the next thing what we need to understand is that if the building is tall enough and air resistance is not negligible, so what we can assume from that? So we can simply assume that the football will finally reach terminal velocity. So this is the first thing we need to conclude from given information. Now we understand the football will reach terminal velocity, so we can sketch velocity versus time graph. As you can see, the velocity on a y-axis, and we can sketch time on x-axis. So if we sketch this graph, this is kind of typical graph at AS level physics. So the graph will look like this. So finally you can see the gradient becomes 0. So from this one, if you look at this point, the gradient means the m is maximum. So we can say value of a is also maximum. And finally, the gradient is equal to 0. So we can also say that acceleration is equal to 0. So one thing I need to explain to you is that gradient of velocity time graph, that is equal to gradient of velocity time graph is equal to a. Is equal to a, is equal to acceleration. That's reason we said when the gradient is maximum, it means a is maximum, and when gradient is 0, it means a is 0, because the gradient of VT graph is equal to a. Now if we have this understanding, and now we can find the best possible option. Now and also we need to understand a is not uniform. A is not uniform. It's non-uniform because its value is changing with time. So we can also say A is non-uniform. Now if you look at this one, at the beginning A has to be maximum, but this one is telling you A is equal to 0. So this is not best option. Okay, option B, if you look at this one is simply telling us that A is maximum, but it is not changing with time. So it's telling us simply that A is uniform, means A is constant. So this is also not best possible option. If you look at D, as you can see here, is also telling you that A is maximum. It's telling you A is 0, but at the beginning A is maximum. So A is 0, this is simply telling you. So this is also not best possible option. So if you look at C, option C now, at the beginning A is maximum, and at the end finally A is equal to 0. So this is according to this. So simply we can conclude our answer, best possible answer for this question is C. Okay, so this is our next question. So let's try to find out what is given to us. First of all, it is given to us that the horizontal component is equal to 20 newtons and angle is also given. So what we need to find out, simply we need to find out vertical component. As you can see, this diagram is also given. The vertical component is on y-axis and horizontal component is on x-axis. So let's try to answer this one now. So I can sketch this one in a little different way. So I can say this is the vertical component. So it's look more familiar. So now how we can find the value of vertical component? So I will simply say horizontal component, let's say as this is the force actually, so the better way is that I also use F here. So this is the force. Now I can say that F at the horizontal component of force will be equal to F cosine of given angle. So if this is as Fh is given to us, that is equal to 20 newtons, 20.0 newtons. So from here we can also write down here that F cosine of 30 degrees, that is equal to 20.0 newtons. So we can find out the value of F. So simply we need to divide 20 by cosine of 30 degrees. If we divide this one, we will get force is equal to 23.1 newtons. So we can update this one. So this is value of 23.1 and this is value of resultant force. Now we need to find the vertical component of force. That is quite straightforward one, that Fv means the vertical component will be equal to F sine of given angle, means this angle. In this case this angle is given, this is equal to 30 degrees. So simply we just need to plug in these values and we will get our final answer. So our final answer for this question will be 11.5 newtons. So this is what we need to find out, vertical component. So our answer is C. For this question, velocity time graph is given to us. As you can see here, the velocity time graph is given. Velocity versus time graph is given. In this case, the car is just moving in a straight line. So it means distance and displacement are the same. So what we need to find out, we need to find out the distance versus time graph we need to find. So how we can answer this question? So the first thing we need to understand is that gradient of displacement time graph, the gradient of dt graph is equal to velocity. So the gradient of displacement time graph is equal to velocity. So now we need to find out, as the velocity is constant here, so from this point to this point the velocity is constant. So it simply means that the gradient of dt graph has to be constant. The gradient of dt graph has to be constant. So this is a gradient of dt graph, mean distance against time graph. As you can see here, the velocity is decreasing. So here we can also say as the velocity is constant. So this is from t0 to t1. So from t1 to t2, so as you can see here, the velocity is decreasing. So it's simply telling us the gradient also has to decrease with time. So this is what, if we have this understanding, then we can answer. Now if you look at option A, so this is simply telling us that this is same, s is not changing with time. So this is absolutely not possible answer. So this is not possible. So it means simply object is at rest, means the velocity is equal to 0. So this is not possible answer. If we look at this one, so the first one is telling us that the velocity is constant. velocity is constant. But the second part is also telling us that the velocity is constant because the gradient is constant. So this is also not possible answer because the gradient is constant. Actually, gradient in the second part from t1 to t2 has to decrease. So this is not possible answer. Now, if we look at C now, at the beginning, you can see the gradient is constant. After that, the gradient is decreasing. So you can see here, first of all, M has to be constant. So M has to be constant. So this is true here. M is constant. So this one is true. And after you can see the gradient is decreasing means the velocity is decreasing, so that is also true. So this can be our answer. So let's also look at option D now. As you can see, gradient constant and is increasing, so this is not possible answer. So our best possible answer for this question is C. This is last question for today's class, so let's try to find out what is given to us. For this question, it is given to us that a resistance can be ignored. So this is the first thing we need to understand. So what we need to find out, we need to find out the changes in horizontal and vertical components of golf ball's velocity. So we need to simply understand when velocity will change if there is force is acting on the object. Means there is a resultant force acting, then its velocity will change. So as a resistance it can be ignored, it simply means that along horizontal, so we can say along horizontal there is no force. So along horizontal there is no force, so it simply tells us that VH will be constant. So VH will stay constant, the horizontal component will not change. And along vertical means in downward direction, as the gravity is acting down, so the force is acting means the gravity is the resultant force that is acting along vertical, and gravity is acting downward. So we can also write down gravity is acting downward. So it means that there will be vertical acceleration, so due to that one, vertical velocity will change. So this will not be constant, or we can simply say object will be accelerating vertically downwards. So if we have this understanding, and this is also the basic concept about projectile motion, so then it is quite straightforward to find our final answer. So as velocity is constant, we can also say horizontal acceleration is equal to 0. And so the vertical acceleration will be equal to g because there is no air resistance. Now let's try to find out answer. Constant deceleration, so this is not possible because AH has to be equal to 0. Constant deceleration, this is also not possible. Constant velocity is possible, so this is correct. Constant acceleration downward, this is also correct. So it means our best possible answer is C. Let's look at part D as well. Constant velocity, that makes sense. Acceleration decreases upwards, that is wrong. So D is not answer. D is not answer. C is our answer for this question. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. This is third video on kinematics and measurements past paper questions from Cambridge AS Physics. If you didn't watch part 1 and part 2, you can go back to the channel and search for kinematics and measurements part 1 and part 2 to fully understand kinematics and measurements. So here is our first question. So let's try to understand what is given to us and what we need to find. So this question is about experiment to find the acceleration of free fall of a body from rest. So what exactly it means? The free fall simply means that we can ignore a resistance, and from rest simply means that the initial velocity is equal to 0. So or we can also say that u is equal to 0. So this is what rest is telling us. So what we need to find out, we need to find the measurements we need to calculate acceleration. So let's first of all try to set up this experiment. How we can find value of g means acceleration, how we can find. So here is ground, as you can see here. Let's say we drop this ball from rest, means initial velocity is equal to 0, and finally the ball will hit the ground at this point. So one way to do this experiment is we can find this height, mean the vertical displacement covered by this ball. I can say this is equal to h. So in this case, as we have h, we have u. So we can use kinematic equation, because in this case acceleration is uniform, so it means we can use kinematic equations. So s is equal to ut plus 1/2 at square. So in this case s is equal to h, we can say s is equal to h. As u is equal to 0, we can simplify, so we will get this is 1/2 at square. So we need to find a, so we can rearrange this equation. We can simply say this will be equal to 2h over t square. So with the help of this equation, we can find acceleration of free fall. So 1h is the height of fall and t is the time taken. So now let's go back to given options and see which one is the best possible answer. For this question, as you can see here, for option A, it is given to us height of fall and time of fall. So this is correct answer. Okay, the second one, height is okay, but we don't need weight actually. The mass we don't need for this one, so this is also not possible answer. The mass we don't need, so this is also not possible answer. So the answer for this question is A. This question is quite straightforward one. If you read this question, you can see it is given to us that acceleration is uniform and the body is moving in a straight line. In this case actually is a particle that is moving in a straight line. So uniform acceleration simply means that its acceleration is constant, is not changing with time. So we simply need to identify which graph can represent the motion of the particle. So in order to answer this question, the first thing we have to understand, it is constant. So the acceleration is constant, uniform, sometimes little confusing for some students, so we can also say that it is constant. So constant acceleration simply means that if we have the velocity time graph, let's say we have velocity on y-axis and we have time on x-axis, so the gradient of this one has to be constant. So in this case, the gradient of vt graph is equal to acceleration. Gradient of vt graph is equal to acceleration. If acceleration is constant, so what it means is that gradient has to be constant. If A is constant, gradient also has to be constant. So if we have this understanding, then we can find answer. So if you look at option A, for example, this is distance against time graph. This is simply telling us that object is at rest. So the velocity is 0. So this is not our answer. If we look at B, the B is simply telling us that velocity is constant. If the velocity is constant, it simply means that acceleration is equal to 0. Now, if we look at option C, now we have velocity on y-axis, we have time on x-axis. As we can see, the velocity is increasing at a constant rate, so we can simply say acceleration is constant. Or another way of understanding is that as its gradient is constant, it means acceleration is also constant or uniform. So this is our answer. But if we look at D now, so this is telling us that acceleration is not uniform, it is non-uniform, it is increasing with time. So D is not answer because D is non-uniform. So this is not our answer. So our answer for this question is C. For this question, motion of two bodies, body X and body Y, is shown on velocity time graph. So it means that we need to understand velocity time graph first of all, and then we can find the best possible answer. So as you can see here, so we have velocity on y-axis and the time is given on x-axis. So time is given on x-axis. So which statement is correct, we need to find out. So here, as you can see, option A is about comparison between acceleration of x and y. B is also about acceleration, and the C is about distance, and D is also about distance. So we have to choose the best possible option from these given 4 options. So how we can answer this question? So the best way to answer this question is, first of all, let's have a look at velocity time graph. Let's say we have velocity on y-axis. As you can see here, this is velocity on y-axis, and we have time on x-axis. So let's say if this is a line on velocity time graph, so what is the gradient of this line? It means the gradient of VT graph, I will simply write down the gradient, that is equal to A. So how about area under this line? I mean area of this graph, area under this graph, this one. So we can say area under graph. So we need to find, so that one in this case will be equal to displacement. So in this case, distance and displacement are same, as these two bodies are moving in a straight line. So now let's try to find out area under x. Area under x, for example, we can find out area under x means this is line, actually this is a triangle. We need to find area of triangle. So area of triangle is simply equal to 1/2 times base times height. So the base is 5, height is also 5. So our final answer will be 12.5 meters. The next we also need to find out area under y. So area under y we can also find out, but area under y we have to be clear about this one, because most of the time students, they just get confused with this one. They don't understand which area they need to calculate. So in this case, let me highlight which area we need to calculate. So this is the area what we need to calculate, means this area. This is the area what we need to calculate. So this area is kind of trapezium, but we can also simplify this one. We can divide this into triangle and rectangle. So if you didn't remember the formula for trapezium, so this is, we can divide into triangle, and also we can divide this one into rectangle. So this is rectangle, as you can see here, rectangle. So the area under X is equal to area of rectangle plus area of triangle. Okay, so how we can find area of rectangle? As you can see, this is 2 is here, so 5 is here, so simply we need to multiply 2 by 5. 2 by 5. So we have to find area of triangle now. So you can see, so area of triangle simply is equal to 1 by 2, and the base, actually base is equal to 5, and the height, this is equal to 1. So this is 1. If we simplify this one, our answer again will be equal to 12.5 meters. So it simply means that the distance traveled by X is the same as distance traveled by Y. Okay, so this is one thing we have found. Now let's try to find acceleration of X. Acceleration of X simply means change in Y, delta Y by delta T. This is delta Y, or we can say delta V by delta T, or you can say delta Y by delta X for gradient. So in this case, that is equal to 5 divided by 5 and is equal to 1 meter per second per second. We can also find acceleration of body Y. Again, same formula, delta Y by delta V by delta T. So in this case, you can see the change in V is 1, means the delta V is equal to 1, and time taken is equal to 5. So the acceleration of body Y is equal to 0.2 meters per second per second. So this is, now if you look at these options now, acceleration of X and Y are the same. So that is not true. That is not true. Initial acceleration of Y is greater as, but we can see here Y is smaller. So this is wrong. Distance traveled by X is greater. No, it is not greater. Actually is equal. Equal. So this is also not answer. The distance traveled by X and Y in the 5 seconds period are the same. Distance is covered. Same. So this is our final answer. So this is how we can answer this question. So only the tricky part is that often students, they make mistake with this part. They don't count area of rectangle. So you need to understand, if this is the situation, you have to consider area of triangle and area of rectangle. This question is about projectile motion, and this question is just testing your basic understanding of projectile motion. So let's try to answer this one now. As you can see, in this case, it is given to us a projectile is fired at an angle alpha to the horizontal at a speed u. So this line is horizontal. It simply means that it makes angle alpha with horizontal, and its initial velocity is u. So what we need to answer, we need to find the vertical and horizontal component of its velocity after a time t. And also you can see here it is given to us that a resistance is negligible. So it simply means that in this case only force acting on projectile is gravity. So simply gravity is only acting, and gravity we understand always acts downwards. Always acts downwards. So this is very important piece of information we need to understand. Now let's try to resolve this one first of all into its components. So the first component you can see is horizontal component of this velocity, and also we can resolve into vertical. Means we resolve into two components, vertical and horizontal. So these are the initial velocity components. Mean horizontal component of initial velocity, we can say that will be u cosine of given angle. In this case, angle is alpha, so we can also write down that is u cosine of alpha. And the vertical component of initial velocity will be u sine of given angle, because this is opposite to this angle, that's the reason it is sine. So this is u sine of alpha. Okay, now as we have already discussed that only gravity is acting on this, and as only gravity is acting, it means there is no force along horizontal, so the horizontal component of velocity will not change. So we can also say that horizontal component of velocity stays same. So horizontal component stays same. Stays same means does not change. Stays same. Stays same. Why? Because no force is acting along horizontal. If there is no force, it means that A is equal to 0. Mean there is no resultant force, so velocity component stays same. Now how we can find, so this is one thing we have found. Now next thing, when we fire this ball, it will follow this trajectory somewhat like this. So now let's say if after time t at this point we need to find the velocity, so velocity will be like this at this point. So we can resolve this velocity into two components. We can resolve into horizontal component, and also we can resolve into vertical component. As horizontal component is not changing, so it will stay same, so this horizontal component will be equal to u cosine of alpha. Now we need to find the vertical component, means vv at this point. How we can find that? So for this one we need to look at vertical motion. So we need to look at vertical motion. So for vertical motion, as we can see, the u initial is given, initial vertical velocity is given, uv I can say, that is given, and that is equal to u sine of alpha. This is given. After time t, means the time is given to us, so I can say in this case time is given, the time taken is equal to small t, and a is also given, a is equal to 9, a is equal to g, because there is only one force acting, that is gravity, so it is equal to g, and that is equal to 9.81, as the acceleration is acting down but the initial vertical velocity is acting up. Now what we need to find? We need to find velocity after time t. This is what we need to find. Now as you can see here, the u is given, t is given, a is given. Simply we can use v is equal to u plus at. Now before we plug in values, we need to understand, as the initial velocity, vertical initial velocity is upwards and the acceleration is down, so we need to take one direction as positive. As the initial direction of motion is up, we will take up as positive to make our calculation simpler. We can also take down, but it doesn't make big difference. But if we take direction of motion positive, it will make our calculation simpler. So if we took up is positive, this component will be, means the initial velocity will be positive, but the value of a will be negative. So now just plug in values, that's all. So we can say u is positive, so this is u sine of alpha minus g times t. So this is over the vertical component of velocity after time t. So if you look at these options, so this is not possible answer. This is also not possible answer. This is correct, but this is correct. This is also. So vertical component and horizontal component, but this one is wrong. This one is also wrong. So our answer for this question is C. So this is how we can answer. So this is a basic concept about projectile motion. So we have to be quite clear about this. Finally, this is the last question for today's class. As you can see, this question is about vectors. What we need to do with these vectors is we simply need to add these two vectors. So it means we need to add vectors p and minus q. We need to add these two vectors together. So what is given to us? In this case, vector p is given and vector q is given. So how we can add vector p and minus q? So minus q, actually this is called negative vector. So the negative vector simply means that its magnitude is the same, but simply its direction is opposite. Means its magnitude is same, only its direction is opposite. So simply we can draw like this. So this one is over minus q. So this one is minus q, mean this is our negative vector. Now we have one vector p and other vector is minus q. So how we can add these two vectors? Simply if we have this vector minus q here, we can just replace this one. We will not change its direction, we will not change its magnitude. We can change its position. We can move from this point to this point. So move to this point now, as you can see here, move to this point now. So this is our vector minus q. Now you can see here, so it's very easy to add these two vectors now. So we can use head to tail method, head to tail method, head to tail method. Tail method. So this is vector p, this is minus q. We need to add these two vectors. So our resultant vector will start from the tail of first vector to the head of last vector. To the head of last vector. So let me little clean this one so you can see a little more clear. So this will be the resultant vector. This will be the resultant vector. So if you look at given options, so D is the best possible option. If you compare this vector with this one, they are similar. So our answer for this question is D. So this is how we can answer. So simple thing, first thing you need to understand what is meaning of minus q. Mean is a negative vector. Mean you no need to change its magnitude. Simply you need to change its direction. That's all. Then just use head to tail method and then you can find the resultant vector. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about Newton's laws and forces. And in this video, I will explain some tricky and challenging questions from Cambridge AS Physics Paper 1. Here is our first question, and this question is about Newton's laws, especially about Newton's second law. So you can read this question first of all by yourself and try to answer this. and then you can come back and you can compare your answer with my answer. So let's try to find out what is given to us for this question. So for this question, the mass of rocket is given here and it is launched from Earth's surface. This is also a very important piece of information, and also the upward force is given to us is here. What we need to find out, we need to find initial acceleration of the rocket. So I have seen this one. Some student, when they read this question, they will recall quickly that F is equal to ma, and then they will say A is equal to F over m, and then they just plug in these values, the upward force, and then they will just divide by the mass and they will write down the final answer, and here they will write down the units, so they will get the final answer. But this is wrong actually. They are missing something. So let's try to find out what is missing. So the best way to answer this type of questions is, first of all, draw free body diagram. So in this case, we can see one force is given that is acting up. That force we can say is F1. Upward force is given, that is here. So this is value of upward force. But also we need to understand, as the rocket has mass, there is also force acting on the rocket due to gravitational field, that is the weight of the rocket that is acting down. So we can say that is F2, and F2 will be equal to mg. Mg, as the m is given, this is value of m, and the g is equal to 9.81 at the surface. So this is very important. Earth's surface. So g, you can take 9.81. So this is now, what is the net force now? So if I need to write down the net force, F net, that will be equal to F1 minus F2. So now you can use Newton's second law. So now we can use Newton's second law. So we can say that A is equal to F net, means the resultant force on the rocket divided by its mass. So resultant force in this case is upward force minus weight. So here we can write down weight. So it is multiplied by 9.81, and all we need to divide by mass. So if we do this one, we will get our answer is 1.2 meters per second, and this is our final answer. Here is our second question, and this is kind of typical question from Cambridge paper 1. So let's try to find out what is given to us first of all. For this question, it is given to us that the ground is frictionless and the wall is rough. So we need to understand what's meaning of frictionless. Frictionless ground simply means that there is no friction, and rough wall simply means that there is friction. So the rough wall, we can say rough wall. So this is simply telling us there is friction. So these two things we have to be very clear. Okay, now what we need to find out, show direction of forces P, W, and R acting on the ladder as it slides. So we need to find directions of P, W, and R. So the first thing we need to understand the weight. For example, weight always acts downwards. So weight always acts down. So this is one. Second, how about normal reaction force? Let's say we place this box on the ground. So the normal reaction force on the box will be acting upwards, and this is always at angle of 90 degree to the surface. So this is what we need to understand about normal reaction force. The third force in this case is frictional force. Now let's say we have this block and it is placed on the ground and the ground is rough. If we apply force F on this block to the right, there will be frictional force acting on this block to the left. So this is frictional force acting on the block to the left. So means friction always opposes the motion. Now let's try to figure out here. Now as you can see here, at this point the force acting is P. Actually this is not right. Actually at this point there are two forces acting. One force is normal reaction force that is at angle of 90 degree to this surface. So this one is N. And as this ladder has tendency to slide down, there is a frictional force acting on this one that is upward. So this is frictional force. So direction of P we can find out. So we can first of all combine these two vectors. So this is our normal reaction force. We just change the place of the vector. So and also here is a frictional force. This is frictional force. So we can find the resultant of these two vectors now. So the resultant will be this. So this has to be actual direction of force P acting on the ladder at this point. And normal reaction force is quite straightforward one. It has to be at angle of 90 degree to the surface. So this is the force acting on ladder at this point. So simply this is what we need to understand. So this has to be direction of P. So this has to be direction of P and this has to be direction of R. A is not correct as we have already seen. But if you look at C, C is also not answer because direction of P is wrong and R direction is also wrong. So this is C is not possible answer. Now if you look at D now, direction of R is wrong and direction of P is correct, but this is not also our possible answer. Now if you look at B now, you can see direction of R means the force on the ladder from the ground. This is R, so this is correct. And also you can see direction of P is also correct and direction of W is also correct. So this is our possible correct answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, we will talk about Newton's laws. And this is second video on Newton's laws past paper questions from Cambridge AS Physics. This question is about mass pulley system, and mass pulley system questions are very common in A-Level Physics and also in AP Physics. These questions are simply based on Newton's laws, especially on Newton's second law. Let's try to find out what is given to us for this question and what we need to find. So in this question, it is given to us there are two blocks. One block has mass capital M, the other block has mass small m. And they're joined by a thin string, means string has no mass and also it is inextensible. And the pulley is frictionless, means pulley has no friction. So what we can conclude from here, so simply based on this data, we can say that capital M is greater than small m. And as the string is thin, is massless, and the pulley is frictionless, it simply means that T1 has to be equal to T2 and it has to be equal to T. So later we will discuss what is T1 and what is T2. And A1 has to be equal to A2 and we can simply say this is A. And because as the string is inextensible, so both masses, they have the same acceleration. So let's try to draw the free body diagram for this mass small m. As you can see, its weight is acting down. We can say this is mg, and the tension in the string is acting up. So that's the reason it will accelerate upwards. So it means upward force has to be greater, and this is the tension. We can say T1. For this mass, we can also draw the free body diagram. As this mass is greater, it means greater force is acting down, and there is a tension that is acting up. So this one is T2. And it is accelerating down, it means downward force is greater. So let's try to draw the free body diagram for small mass. For small mass, simply we can say as upward force is greater, so we can say the T1 minus mg has to be equal to m times A1. And for the bigger mass, we can also draw the free body diagram. As you can see, we already have free body diagram. We can write down the resultant force. So this is mg minus T2, mean mg is greater than T2, and this has to be equal to capital M, means the mass of that block is capital M, and acceleration we can say is A2. As we simply understand, A1 is equal to A2, as you can see here, we have already written here, and T1 is equal to T2. So simply if we add these two equation, let's say this is equation 1 and this is equation 2, if we add them, simply we can cancel. This T1 is plus, this T2 is minus, but T1 is equal to T2. So we can simply cancel these two. So what we left with mg minus small mg, and this is equal to small m plus capital M, and we can take common A. A1 is equal to A2, so we can simply take common A. So we need to find A, so we can simply say that capital M minus small m, and this is multiplied by G divided by capital M plus small m. So this is how we can find the answer. And so in this case, answer will be B, as you can see here. So this is our answer. So this method is little long, but if you have understanding of this one, so we can also use a shortcut method. Simply we can say A has to be equal to F net, means the resultant force acting on the system divided by the total mass of the system. So in this case, as we can see, these two forces are acting in opposite direction. One is acting on the left side, this is acting down, and the other one is acting on the right side, and also this is acting down. Actually, these two forces are acting in opposite direction. So it simply means we can write down mg minus small mg. So this is the resultant force acting on the system, as pulley has no friction. And what is the total mass of the system? As the string has no mass, so total mass of the system is capital M plus small m. So this is how we can find A directly with this one. So this is a shortcut way we can simply use, and we can find acceleration of the system. This is our second question, and this question is about a street lamp. A street lamp that is attached to a fixed wall by a metal rod and a cable. So as you can see here, the cable is here and the metal rod is here, and the lamp is attached at this point, and here is the wall. So what we need to find? We need to find which vector triangle can represent the forces acting at point P, and here is point P. So for this one, we simply need to understand the forces acting at point P, and also we need to be careful with direction of forces. Now the first force we need to understand acting at this point is the weight of the lamp. The weight of the lamp is acting down. We can say this is W lamp. and there is a force acting on the rod actually from the wall, and this force is acting to the right. We can say this is F rod, mean horizontal force of the rod, and the tension in the cable is acting in this direction. So based on this one, simply we can answer this question. So as you can see here, this direction is up, so this is wrong, this is also wrong, and this direction is to the left, this is wrong because it has to be to the right. So this is also wrong. Now our answer can be B or an answer can be D. So let's first of all look at B now. This is good, but this is also good, but this is wrong. Direction of tension actually is wrong. So this can't be our final answer. So look at this one now. This is correct. Direction of horizontal force of the rod is also correct, and direction of tension is also good. So our best answer is D. And this is our final answer.
Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss a typical question on Young's modulus from Cambridge AS Physics. Young's modulus is also called modulus of elasticity, and today's question is very important on this topic because this type of questions are very common in past papers. For this question, it is given to us that a student is investigating the mechanical properties of a metal and he has plotted a graph of stress against strain. The student also repeats the experiment with a wire that is made from the same metal but its dimensions are different, its length is double and its diameter is half. We need to simply find out which graph he will obtain from these given four options. Actually, this question is simply based on Young's modulus. Let's try to understand what exactly is Young's modulus. Young's modulus is also called modulus of elasticity. Modulus of elasticity. Elasticity we need to understand because this is also a very important concept. It is called modulus of elasticity because elasticity is the ability of a material to regain its shape. If a material has higher ability to regain its shape, its Young modulus will be higher. If it has low ability to regain its shape, its Young's modulus will be lower. For example, Young's modulus of steel is higher than Young's modulus of rubber. Now let's try to understand what is the relationship between Young's modulus and stress and strain. Young's modulus is the ratio between stress and strain. So simply we can say stress divided by strain. So you can use Y or you can use E. Now, we also need to understand that Young's modulus is property of material. Like the resistivity, resistivity is a property of material that does not depend on dimensions. And same Young's modulus is also property of material. So first thing we need to understand is this is property of material. It depends on type of material but does not depend on dimensions. We will go to that point later. It depends on type of material. It depends on type of material. It simply means that let's say we have one wire, this is made of copper, and let's say we have another wire and the second wire also have the same dimensions, but this wire is made of steel. So the Young's modulus of copper wire in this case will not be equal to Young's modulus of steel because these are two different materials. And the second thing we need to understand about Young's modulus is that that it is independent of dimensions. So it is independent of dimensions. What exactly it means by independent of dimensions? It simply means that, let's say we have one wire and this wire is made of copper. And we have another wire and this wire is also made of copper. But for this wire this is L, and for this wire L1, let's say, and this is equal to 2 times of L, and let's say the diameter of this wire, this is D, and the diameter of the second wire, this is D by 2. Now these two wires, they are made of the same material. Even the dimensions are different, but Young's modulus for these two wires is the same because they are made of the same material. So it simply means that Young's modulus does not depend on dimensions. So it is property of material. If temperature is the same, Young's modulus is the same for a wire if the wire is made of same material. So if Young's modulus is the same, so we can also say that for the same stress, for example, if Young's modulus is the same and at the same stress there must be same strain. So strain also has to be same. So from here we can simply conclude that if the wire is the same, so the graph we will obtain, that also has to be the same. Graph has to be identical. Even the dimensions of the wire are different because the student is using an other wire that has different dimensions but is made of same metal, made of same material. So Young's modulus is the same. For any value of stress in the wire, strain also has to be the same because Young's modulus is property of material. If the wire is same, Young's modulus is also same. This is our graph of first wire. You can see this is the graph of first wire. So simply we can say this is for first wire. This is graph. This has to be the graph for second wire because these two graphs has to be identical. So this is graph for second wire. Graphs are identical. Why? Because it is made of same material. So our answer for this question is B.